What if the moon has been keeping a secret from us this entire time? Not a small one, not a trick of shadow or a faint marking on its surface. A secret the size of a mountain range, buried on the one side of itself it never allows us to see. For as long as human beings have existed, we have watched the same grey face hanging in the night and felt that we knew it. But turn the moon around, sink beneath the floor of its greatest crater, and there is a weight down there in the dark that should not, by all the rules we think we understand, even be where it is. It bends the crust out of shape. It tugs at spacecraft that pass overhead, and it has waited motionless for 4 billion years, longer than there has been complex life on Earth. We can feel its pull, we can measure its weight, and still, nobody can say for certain what it is. So where did it come from? This enormous buried thing, a visitor that fell from the sky, or a piece of the moon's own hidden past? Settle in and make yourself comfortable. Subscribe if you have not already, and stay with us tonight, because to understand what is down there, we have to go all the way back to a time when the moon itself was an ocean of fire. Let's get into it. Part 1. The side we never see. There is a face of the moon that no human being saw for almost the entire history of our species. Think about that for a moment. For hundreds of thousands of years, people looked up at the same grey disk hanging in the night. They named it, worshipped it, sailed by it, fell in love under it, and told their children stories about the shapes they thought they could see in its light. And in all that time, across every civilization that ever lived and died, not a single person ever laid eyes on the other side of it. The moon keeps one face turned toward us and one face turned away, always, and it has done so for longer than there have been eyes on Earth to notice. The far side stayed a secret until the 7th of October, 1959, when a small Soviet probe called Luna 3 swung around the back of the moon and sent home the first blurry photographs of a place no one had ever seen. And what those first grainy images began to reveal, and what every mission since has confirmed, is that the side we never see is not just unfamiliar, it is a different world. That is where our story begins tonight, because somewhere on that hidden hemisphere, buried under a scar so enormous it would stretch most of the way across a continent, there is something we cannot explain, something dense, something heavy enough to bend the crust of an entire world, something that has been sitting there, in the dark, for about 4 billion years, and which we only learned how to detect within the last decade. It does not glow, it does not move, it sends no signal, and yet it is there, and it is real, and the scientists who found it will tell you plainly that they are not certain what it is. Tonight we're going to go and find it. We're going to travel to the side of the moon that stayed hidden through all of human history, sink beneath the floor of the largest crater in the solar system, and sit with one of the strangest facts anyone has ever measured about our nearest neighbour. Before we go down, though, we have to understand where we're going, because the far side of the moon is a genuinely strange place, and its strangeness is part of the mystery. When people first got a good look at it, they expected it to be more or less a mirror of the side we know. It is not. The face we see, the familiar one, is smooth and calm. It is covered in those large, dark, flat plains that the earliest astronomers mistook for oceans and named the Maria, the Latin word for seas. They are not water, of course. They are enormous sheets of ancient volcanic rock, frozen lava that welled up from inside the moon billions of years ago and flooded across the surface, leaving behind the dark patches that form the shape people around the world have variously read as a face, a rabbit, a woman carrying sticks. That near side is, in a sense, a paved-over world, its old wounds filled in and smoothed over by that dark rock. The far side is nothing like it. When you finally see it, the first thing that strikes you is how rough it is. There are almost none of those dark, smooth plains. Instead, there is crater upon crater upon crater, a battered, mountainous, pale surface that looks older and more brutalized than the face we know. The crust on that side is thicker. The whole hemisphere sits higher. It is geologically a different animal, and the difference between the two sides of the moon is so profound that scientists have argued about its cause for more than 50 years. They call it the lunar dichotomy, the two-faced moon, and we will come back to it later because it turns out to be tangled up with the thing we are hunting. For now, just hold on to the image. The moon you know is the calm side, The side turned away from us is the scarred one, and the deepest scar of all is where we are headed. That scar has a name. It is called the South Pole Aitken Basin, and it is, without exaggeration, one of the most impressive features in the entire solar system. It is an impact crater, a hole punched into the moon by something that hit it long ago. But the word crater does it a disservice, because when you hear crater, you probably picture something you could walk across in an afternoon. This is not that. Measured from one outer rim to the other, the South Pole Aitken Basin spans roughly 2,500 kilometers. That is about 1,600 miles. If you set it down on the surface of the Earth, it would reach from the northern border of the United States nearly to the Gulf Coast in the south. It plunges around 13 kilometers from rim to floor, some 8 miles, farther down than the lowest ocean trench on Earth. It is the largest, deepest, and one of the very oldest impact basins on the Moon, and as far as we know, it is the single largest confirmed impact crater anywhere in the solar system. Nothing on Mars, nothing on Mercury, nothing on any moon of any giant planet has a confirmed impact scar quite this big, and almost all of it is on the far side. That is why, for most of human history, no one knew it was there. You cannot see it from Earth. Not really. Not from where we stand. Its existence was first suspected in 1962, when scientists squinted at the primitive far-side images from those early Soviet probes and thought they could make out the edge of something enormous. It was confirmed a few years later, in the mid-1960s, when NASA's Lunar Orbiter spacecraft mapped the region properly. But its true size, its true depth, its sheer scale, only came into focus with modern instruments, with lasers fired from orbit that could measure the height of every ridge and the depth of every valley down to a few meters, and the more sharply we mapped it, the more it became clear that this was not just a big crater. This was a wound left over from a day of almost unimaginable violence, near the very beginning of the Moon's life, and something about that day left a mark that goes far deeper than the surface. Here is what I want you to picture as we prepare to go down. Imagine standing on the floor of that basin. There is no air, so there is no sound and no wind, and the sky above you is pure black even in daylight, crowded with stars that never twinkle. Grey rock stretches to every horizon, older than almost anything you could name, cratered and battered and still. And here is the strangest part of standing there. If you look up, you will not see the Earth. On the near side of the Moon, our blue world hangs permanently in the sky, never rising, never setting, always in the same spot, a comfort and a companion. But you are on the far side now, and the Earth is gone. It is on the other side of an entire world, hidden behind the Moon's bulk, and it never once appears. You would stand there, on the deepest scar in the solar system, more alone than any human has ever been, with no home world in the sky to look back at. No person saw this ground at all until a single human lifetime ago. And beneath your boots, though you would have no way of feeling it, something enormous is pulling the rock you stand on gently, silently, downward. It is worth pausing on why we only ever see one face of the Moon at all, because it is not a coincidence, and it is not because the Moon fails to spin. The Moon does turn on its axis. It is simply that it turns at exactly the same rate that it circles the Earth, completing one full rotation in precisely the time it takes to make one trip around us, a little under a month. The two motions are locked together in perfect step, and the result is that the same hemisphere is always pointed our way. This is called tidal locking, and it is not unique to our Moon. It happens all across the solar system, to moons circling the giant planets, because over long stretches of time the gravity of a large body gently tugs on the rotation of a smaller one and slowly brings it into this kind of lockstep. Our Moon fell into that rhythm billions of years ago, and it has kept it ever since. So the far side is not hidden by darkness, and it is not hidden by distance. It is hidden by the simple, elegant geometry of two motions turning in perfect time. The far side receives just as much sunlight as the near side over the course of a month. It is not the dark side, whatever the old phrase suggests. It is only the side turned away from us, permanently, by the clockwork of gravity. And that clockwork is exactly why the far side stayed a secret for so long, and why everything we have learned about it is so startlingly recent. Until we could build machines that fly beyond the Earth, there was no way, none at all, to see around the back of the Moon. You cannot walk far enough. You cannot climb high enough. There is no mountain, no ship, No vantage point anywhere on our planet from which the far side becomes visible. The only way to lay eyes on it is to physically travel out into space and go around, and no human being and no human machine could do that until the middle of the 20th century. This is one of those facts that is easy to state and surprisingly hard to truly absorb. Fire, farming, writing, mathematics, the wheel, the printing press, sailing ships that crossed every ocean on Earth, entire civilizations rising and falling and rising again, all of it came and went, and through the whole of it, the far side of the moon remained a total blank. Not misunderstood, not badly mapped, simply unseen by anyone, ever. The generation alive when Luna 3 sent back those first grainy pictures in 1959 was the first generation in the entire history of our species to know what the other side of the moon even looked like. That is how new our knowledge of this place is, and it is on this barely explored hemisphere, the newest map humanity possesses of anything, that our mystery is buried. There is one more thing about the far side that makes it feel almost designed to keep secrets, and it has to do with silence. Because that hemisphere always faces away from Earth, it is also permanently shielded from the noise of Earth. Every radio broadcast, every phone signal, every burst of electronic chatter our civilization pours into the sky, the far side of the moon never hears any of it, because the entire bulk of the moon sits between that surface and our planet, blocking it out. Radio astronomers actually dream of building telescopes there for exactly this reason, in the quietest patch of real estate anywhere near Earth. But turn that fact around and it becomes something stranger. The far side is not just a place we cannot see, it is a place that cannot see us, a hemisphere that has spent 4 billion years turned away from the world that made it, staring out only at the empty stars. And somewhere in the middle of that turned away, radio-silent, barely mapped half of our closest companion, a weight has been waiting in the rock, patient and enormous, since long before anyone existed to be curious about it. That is what we came to find. So let us go and find out how anyone could possibly know it is there. Part 2. The twins that felt the tug. The obvious question before we go any further is a fair one. If this thing is buried hundreds of kilometers underground, on the side of the moon we cannot even see, how could anyone possibly know it exists? You cannot dig down to it. You cannot fly a camera into solid rock. No telescope on Earth, no matter how powerful, can look through 200 miles of stone. So how do you find something that gives off no light, no heat, no radio signal and sits sealed inside another world? The answer is one of the most elegant tricks in all of science, and it comes down to a single force that you have felt every second of your life without ever thinking of it as a tool: gravity. Everything with mass pulls on everything else. You know this instinctively. The Earth pulls you down into your chair. The moon pulls on the Earth's oceans and drags the tides back and forth twice a day. But the rule goes deeper than that, and it is more useful than you might expect. The strength of gravity's pull depends on how much mass is nearby and how close it is. Pile up more mass in one spot, and the pull there gets a little stronger. Thin the mass out, and the pull gets a little weaker. This means that if you could measure the strength of gravity with enough precision, point by point, across the surface of a world, you would essentially be making a map of where the mass is piled up and where it is thin, including mass that is hidden underground. A dense lump buried far below the surface would announce itself, not by anything you could see, but by pulling a fraction harder on anything that passed overhead. The trick, the entire trick, is being able to measure that pull precisely enough to notice. And measuring it precisely enough is extraordinarily hard, because the differences we're talking about are tiny. The extra tug from a buried mass might change the local strength of gravity by a fraction of a percent or far less. To catch something that faint, you need an instrument of almost absurd sensitivity, and in 2011 and 2012, NASA flew exactly that. The mission was called GRAIL, which stands for the Gravity Recovery and Interior Laboratory, and it was one of the most beautifully simple ideas in the history of planetary exploration. It was not one spacecraft. It was two twin probes, each about the size of a washing machine, and they were sent into orbit around the moon flying in formation, one chasing the other around the same circular path, separated by a couple of 100 kilometers of empty space. NASA, in a lovely touch, let schoolchildren name them, and the winning names were Ebb and Flow, after the movement of the tides that the moon itself creates. Here is how the two of them work together, and it is genuinely clever. Ebb and flow constantly beamed radio signals back and forth to each other, measuring the exact distance between them with staggering precision, down to a fraction of the width of a human hair. That distance was the whole experiment. As the lead spacecraft flew over a region where the moon's gravity was slightly stronger because of some concentration of mass below, it would get tugged forward and speed up by the tiniest amount. That would stretch the gap between the two probes just a little. Then, moments later, the trailing spacecraft would reach that same spot, feel the same tug, speed up in turn, and close the gap again. By watching how that gap between them stretched and shrank over and over, millions of times, across every part of the moon, the mission built up the most detailed gravity map ever made of any world in the solar system, including our own Earth. It could feel the moon's mountains and basins, and crucially, it could feel the hidden masses buried beneath them. I want to slow down and put you there for a moment, because it is one of the quietest and strangest kinds of discovery there is. Imagine you are riding along with Ebb, the lead spacecraft, in orbit low over the far side of the moon. There is no sound, of course, and no sensation of speed. Below you the grey, cratered ground scrolls slowly past, harsh and lifeless, and a couple of 100 kilometres behind you, if you could look back, there is a single point of light, your sister ship Flow, following faithfully in the same track. For most of the orbit, nothing happens. The distance between you and your twin holds perfectly steady, measured every instant by that thread of radio passing back and forth. And then the ground below you begins to change. The land drops away into the enormous shallow bowl of the South Pole Aitken Basin, and as you cross it, something invisible reaches up and touches your spacecraft. You feel nothing. There is nothing to feel. But the instruments feel it. You're being pulled forward, faster, by a fraction of a whisper, tugged by a weight buried far below the floor of the crater. The gap between you and your sister ship stretches by less than the width of a hair. And that impossibly small change, that tiny quickening as you pass over the basin, is the entire discovery. There is no flash, no alarm, no dramatic moment. There is only a machine being pulled, gently and silently toward a mass it will never see, and a number ticking in a computer back on Earth. Because that is the thing to hold on to. You have felt gravity every second of your life, and never once thought of it as an instrument, but used with enough care, gravity becomes a searchlight, a way of feeling into places you can never go and finding things you can never see. The same force that holds you in your seat right now, that keeps your feet on the floor, is the force that let us reach hundreds of kilometers into the body of another world and feel the outline of something hidden there. We did not see the buried mass. We felt its weight, indirectly, through the pull it exerted on two small robots, and that was enough. Let me try to convey just how small the measurements were that made this discovery possible, because the sensitivity involved borders on the unbelievable. The two Grail spacecraft measured the distance between themselves, across a gap of a couple of 100 kilometers, to a precision finer than the width of a human hair. Sit with that for a second. Two machines, hundreds of kilometers apart, orbiting another world, tracking the space between them so precisely that they could notice a change smaller than the thickness of a strand of hair pulled from your own head. That is not a figure of speech. That is the actual level of precision. And it had to be that precise, because the thing they were hunting for announces itself so faintly. The extra tug from a buried mass does not yank a spacecraft violently off course. It nudges it, by an amount so tiny that only an instrument measuring hair widths across hundreds of kilometers could ever hope to feel it. The discovery of something enormous, in the end, depended entirely on our ability to measure something almost infinitesimally small, and I think there is a genuine kind of beauty in the method, worth dwelling on before we get back to the number itself. We did not find this buried mass by brute force. We did not blast into the moon, or drill into it, or fly a probe into its interior. We found it by paying exquisitely careful attention to the way two small robots drifted, and by trusting a single, simple law of nature that mass pulls on mass, enough to follow it to a conclusion we could not see with any eye or any camera. There is something almost tender about it. The universe does not hand over its secrets loudly. It offers them in whispers, in the barely perceptible quickening of a spacecraft, in a gap that stretches by less than a hair, and it takes patience and precision and a willingness to listen closely to hear what those whispers are saying. Everything we know about the thing buried under the moon, we learned by listening that carefully to a pull too gentle for any human being to ever feel. It is also worth appreciating that this is the same physics that touched the astronauts of the Apollo program, which grounds the whole story in something very human. The mass concentrations inside the moon, the buried weights we will come back to later, were significant enough that the men who flew to the moon and the engineers who guided them had to account for their invisible tugs to navigate safely. When you were a person sitting inside a small spacecraft circling the moon, trusting a computer to bring you down to a precise spot on the surface, the hidden mass inside that world was not an abstraction. It was reaching up through the rock and gently altering your path, and if you ignored it, you could miss your mark. So this business of buried mass pulling on things overhead is not some exotic modern curiosity. It has been quietly shaping human spaceflight since the very first missions, tugging at the paths of the first people ever to leave the Earth behind. The gravity of what is hidden inside a world reaches all the way up to the surface and beyond, and touches everything that dares to orbit it. But gravity alone, it turns out, is not quite enough to solve the puzzle by itself, and understanding why is the key to the whole thing. A strong gravity signal in one spot could mean many things. It could be a mountain range on the surface, all that piled up rock pulling harder. It could be a dense lump buried far below. From the gravity map alone, you cannot always tell the difference between a weight on top and a weight underneath, because both of them pull. To find something hidden, you have to be able to account for everything you can already see, subtract it all away, and look at what is left over. And to do that, Grail needed a partner, another spacecraft that had already been quietly building the other half of the answer, one laser pulse at a time. That partner is where the real detective work begins, and it is where the number that startled the whole world first appeared. Part 3. 5 Hawaiis of Buried Metal. The partner was a spacecraft called the Lunar Reconnaissance Orbiter, which most people just call LRO. It has been circling the moon since 2009, and among its many instruments is a laser altimeter, a device that does something wonderfully straightforward. It fires a pulse of laser light straight down at the surface, waits for the light to bounce back, and measures exactly how long the round trip took. Because we know the speed of light with tremendous precision, that travel time tells you exactly how far away the ground is, and therefore exactly how high or low that piece of surface sits. Fire that laser millions upon millions of times as the spacecraft sweeps over the whole moon, and you build up a map of the shape of the surface so detailed that you can measure the height of a ridge or the depth of a crater floor to within a meter or so. LRO had, in effect, traced the entire skin of the moon, every bump and hollow, in exquisite detail. Now put the two datasets together, and you can see the detective work. On one side you have Grail's map of where the moon's gravity is stronger and weaker. On the other you have LRO's map of the exact shape of the surface. A scientist can take the surface map and calculate precisely how much gravitational pull all that visible rock ought to produce. Every mountain, every crater wall, every ridge, adding up all the mass you can actually see. Then you subtract that calculated pull from the pull that Grail actually measured. If the two match, then everything is explained by what is on the surface, and there is nothing hidden. But if there is gravity left over, a pull that the visible surface cannot account for, then that leftover pull must be coming from something underground, something you cannot see. That is exactly what a team led by Peter B. James, a planetary geophysicist at Baylor University, set out to examine beneath the South Pole Aitken Basin. And when they did the subtraction, the leftover signal was not small. It was enormous. In the spring of 2019, James and his colleagues published their findings in a scientific journal called Geophysical Research Letters, in a paper with the appropriately grand title, Deep Structure of the Lunar South Pole Aitken Basin, and buried in the careful language of that paper was a number that would ricochet around the world's headlines within days. Beneath the floor of the basin, hidden in the moon's mantle, the layer of rock between the crust and the core, there was a concentration of excess mass so large that the team's minimum estimate, the smallest amount they could possibly account for, was 2.18 times 10 to the 18th kilograms. Let me say that in plainer words. That is roughly 2.18 quintillion kilograms of extra unexplained material. A quintillion is a 1 followed by 18 zeros. It is a number so far beyond ordinary experience that saying it out loud does almost nothing to convey it, and James clearly knew that, because when reporters asked him to explain, He reached for an image instead of a figure. Imagine, he said, taking a pile of metal 5 times larger than the big island of Hawaii and burying it underground. That, roughly, is how much unexpected mass they had detected. Sit with that comparison for a second, because it is doing a lot of work. The big island of Hawaii is not a small place. It is the largest island in the Hawaiian chain, big enough to hold several of the other islands inside it with room to spare, a landmass of thousands of square kilometres built from the accumulated output of enormous volcanoes. Now take that entire island, and 4 more just like it, and picture all of that mass, not spread out on the surface where you could see it, but compressed and sunk into the body of the moon, buried far below the ground. That is the scale of the thing hiding under the South Pole Aitken Basin, and it is not resting just beneath the surface. The anomaly, as scientists call it, likely extends to depths of more than 300 kilometres, around 200 miles, reaching far down into the mantle of the moon, and it is so heavy that it is doing something visible to the world around it. A mass that large, sitting in the mantle, pulls down on everything above it, and over billions of years that relentless downward pull has physically deformed the crater sitting on top of it. The entire floor of the South Pole Aitken Basin, that enormous 2,500 kilometre bowl, is pressed downward by more than half a kilometre, more than 8/10 of a kilometre, more than 1/4 of a mile deeper than it would otherwise sit, sagging under the weight of whatever is buried below. Think about what that means. Something at the bottom of the largest crater in the solar system is heavy enough to bend the crust of an entire world, to pull the ground down toward itself and keep it there, permanently, for 4 billion years. Not with a sudden collapse, just with the patient, unstoppable pull of enormous mass, hour after hour, century after century, since before there was complex life on Earth. I want you to feel the strangeness of this, because it is easy to hear a number like 2.18 quintillion kilograms and let it slide past you, and that would be a mistake. So do not try to hold the number, build it instead. Picture 5 entire Hawaiian islands worth of metal. Now bury them, not just underground, but sunk 200 miles down into the body of the moon, so far below the surface that no drill humanity has ever built could reach a fraction of the way there. Now make that buried mass so heavy that the ground for 1,000 miles in every direction sags toward it, the whole crust of a world dented inward under the strain. And now realize that it has been sitting exactly like that, silent, in the dark, on the side of the moon that faces away from us, since before the first fish crawled onto land, before there were forests, before there was almost anything alive on Earth at all. Every tide the moon has ever pulled, it pulled while carrying this. Every eclipse it has ever cast across our planet, every full moon that ever lit a road home for someone, it did all of it with this thing buried in its far side, and it never once showed it to us. Not because it was hiding it on purpose, simply because the side it was buried in is the side we cannot see. That is the feeling the thumbnail is reaching for when it says this is scary. It is not the fear of danger. This mass is not going to hurt anyone. It does not affect our tides. It does not tug on the earth. It is not going anywhere, and it has no more power over your life than the mountains on the far side do. The unease is something older and quieter than fear of harm. It is the vertigo of discovering that the most familiar object in your entire sky, the moon you have looked at your whole life and felt you understood, has been carrying something the size of a mountain range hidden inside it, in a place you were never able to look, the entire time. It is the feeling of certainty cracking. You thought you knew the moon, and it turns out you knew the front of the postcard. The rest was sealed and full. Let me try to make that depth of 300 kilometres real, because it is easy to say and hard to feel. 300 kilometres is roughly the distance a car would cover in 3 hours of highway driving. Now stand that distance up on its end and drive it straight down into the ground. If you started at the surface and travelled 300 kilometres straight down into the earth, you would pass entirely through the crust, which is only a few tens of kilometres thick, and plunge far into the mantle below, into a region of such heat and pressure that no human technology has ever come remotely close to reaching it. That is roughly how far down the top of this anomaly begins, and it extends downward from there. To put it another way, the deepest hole human beings have ever drilled into our own planet, after years of effort, reached about 12 kilometres before conditions became impossible. The buried mass under the moon starts at more than 300. We're talking about something so far beneath the surface that the entire history of human digging, on our own planet, would not scratch a 20th of the way to it. And yet, from that impossible depth, it makes itself felt at the surface, which is the part that never stops being remarkable to me. A mass buried that far down, in the interior of another world, still manages to reach up through hundreds of kilometers of solid rock and press the crust downward, still manages to tug at spacecraft flying overhead, still manages to leave a fingerprint in a gravity map made by two little probes. It is a reminder that in the physics of large bodies, nothing is ever truly sealed off. The inside of a world is always, quietly, in conversation with its outside. Pile up enough mass anywhere inside a moon or a planet, and its influence will find its way to the surface eventually, in the sag of the ground, in the strengthening of gravity, in the paths of everything that passes above. The moon cannot fully hide what it carries. It can only bury it, and the burial, given enough mass, is never quite complete. There is one more comparison worth making because it connects this hidden thing to something you can actually see. The near side of the moon has those great dark plains, the Maria, and beneath several of them sit the classic mass concentrations we mentioned, buried weights heavy enough that they too bend spacecraft orbits. But those near-side masses have a visible explanation right there on the surface, the dark flood of ancient lava that filled the basins. You can look up at a full moon on a clear night and see, with your naked eye, the dark patches that mark where some of those buried weights lie. The South Pole Aitken anomaly has no such calling card. There is no dark plane over it, no obvious surface feature that says here is where the weight is. It is far larger than those near-side masses, it sits far deeper, and it hides beneath a crater floor that looks, from above, like nothing special at all. You could stare at the best photograph of the far side ever taken and never guess that beneath one particular stretch of ordinary grey ground, something 5 times the size of Hawaii is pulling the world out of shape. So the number is real, the mass is real, the pull is real, and we can feel it. But knowing that something enormous is down there is not the same as knowing what it is. And that is where the real mystery opens, because when you ask the scientists who found it the most natural question in the world, what is it? They will look at you honestly and tell you they are not sure. There are 2 very different answers, and nobody has been able to prove which one is right. Part 4. The question with no settled answer. This is the part of the story that I find the most fascinating, because it is where science stops being a list of confident facts and becomes something more honest, and in a way more human. We have measured the mass. We know almost exactly how heavy it is, how far down it sits, how much it is bending the crust. We have numbers to many decimal places, and yet the single most basic question a curious person would ask, what is this thing made of and how did it get here, does not have a settled answer. When you read the actual scientific paper, you find the researchers laying out 2 possible explanations side by side and stating, plainly, that they cannot yet be sure which one is correct. That is not a failure. That is exactly what honest science looks like when it runs into something genuinely hard. But it does mean that the truthful answer to what is buried under the moon is, at this moment, we have 2 very good guesses and no proof. The 2 guesses could hardly be more different from each other, and that is part of what makes the mystery so compelling. The first suspect comes from outer space. It proposes that the buried mass is a piece of the very object that carved the crater in the first place, the shattered metal remains of an ancient asteroid, still lodged in the moon's mantle 4 billion years after it struck. The second suspect comes from within. It proposes that the mass has nothing to do with any asteroid at all, that it formed inside the moon itself, a concentration of dense material left behind when the young moon was a globe of molten rock and slowly cooled and hardened. One story says a killer fell from the sky. The other says the moon is hiding a piece of its own past, and the strange, frustrating, wonderful truth is that both stories fit the evidence we have. The gravity data does not by itself tell them apart. Before we follow each suspect down its own path, it is worth understanding why this is such a hard question to answer. Because the difficulty is not laziness or lack of effort. It is physical. The mass is buried more than 300 kilometers down. No spacecraft, no drill, no probe humanity has ever built or seriously proposed could reach 1/10 of that depth. The deepest hole ever drilled into the Earth, after years of effort with the full weight of an industrial superpower behind it, reached about 12 kilometers before the heat and pressure became too much. 12 kilometers on our own planet at enormous cost. The lunar anomaly sits at more than 300. We are never going to touch it directly. We cannot bring a sample of it back. We cannot photograph it. Everything we will ever learn about it for the foreseeable future has to be inferred, deduced from its gravity, from the shape of the land above it, from the chemistry of rocks that the ancient impact might have thrown up from below, and from computer models that try to reconstruct what happened 4 billion years ago. We are detectives who can never enter the room where the crime took place. We can only work from the evidence that leaked out under the door, and that changes what a good answer even looks like. In a lot of science, you settle a question by going and measuring the thing directly. You cannot do that here. So instead, the question becomes a kind of trial, with 2 suspects, and the job is to weigh the evidence for each and see which story explains more of the facts, with fewer awkward contradictions. As we'll see, each suspect has strong evidence in its favour, and each has at least one serious problem it has to explain away. The asteroid theory has to explain why a lump of dense metal has not simply sunk to the centre of the moon over 4 billion years, the way heavy things are supposed to. The magma ocean theory has to explain how a concentration of dense material ended up gathered right there, under the biggest crater, rather than spread evenly around the moon. Both problems have possible solutions. Neither solution has been proven. That is the honest state of the case. I think it is worth pausing to appreciate that honesty, because there is a temptation, whenever science says we do not know, to hear something ominous in it, as if the uncertainty were hiding a secret or covering something up. It is not. This is simply what the edge of knowledge feels like. A century ago we did not know what powered the sun. A few decades ago we did not know whether other stars had planets. Not long ago the far side of the moon itself was a total blank, a hemisphere no one had seen. Every one of those blanks eventually got filled in, not by someone confessing a hidden truth, but by patient people building better instruments, gathering more evidence, and arguing carefully with each other in the open until the answer became clear. The buried mass under the moon is one of those blanks, caught in the act of being filled in. We are living in the exact stretch of time when the question is open, when reasonable scientists genuinely disagree, and when the tools that might finally settle it are only just coming online. That is a rare and lucky thing to witness. Most mysteries are either already solved or still completely dark. This one is right on the line. There is something I want to name directly about these 2 suspects, because the contrast between them is part of what makes this mystery so satisfying to think about. They are not just 2 different explanations, they are 2 completely different kinds of story about where things come from. The asteroid theory is a story about something arriving from outside, an intruder, a visitor, a piece of the wider solar system crashing into the moon and leaving its wreckage behind. It is a story about the moon being marked by the chaos around it. The magma ocean theory is the opposite. It is a story about the moon generating the mass from within, out of its own body, out of the slow settling of its own molten beginnings. It is a story about the moon being marked by its own nature. One says the strangeness came from the sky, the other says the strangeness was always inside. And the honest, remarkable truth is that we cannot yet tell whether the biggest buried thing in our neighbour is a wound inflicted from outside or a birthmark carried from within. I also want to be careful, here at the pivot of the whole story, to be precise about what we actually know versus what we are guessing, because that distinction is the entire spirit of how this channel approaches a mystery. What we know, with real confidence, is a short and solid list. We know the mass is there. We know roughly how heavy it is, at least 2.18 quintillion kilograms as a minimum. We know it sits hundreds of kilometres down, in the mantle beneath the basin. We know it is dense enough that metal is a natural fit, and we know it is deforming the crust above it. Those facts are measured, checked, published, and not seriously disputed. What we do not know is everything about its origin, its exact composition, its precise shape, and its full size, since 2.18 quintillion kilograms is only the floor of the estimate, the least it could be. The line between those 2 lists, between the measured and the guessed, is exactly where the mystery lives, and a good storyteller and a good scientist both have to respect it. We are not going to pretend the guesses are facts, but we are also not going to pretend the facts are not extraordinary, and I think it helps to sit for a moment with why this particular kind of not knowing is so common in the study of other worlds, because it will come up again and again on this channel. When you study something happening now, you can often just go and look. But when you study something that happened 4 billion years ago and left its evidence sealed inside a planet, you become less like an observer and more like a detective working a very cold case. The witnesses are long gone. The scene has been buried and reburied for eons. All you have are the traces that survived, and often those traces are consistent with more than one version of events. Good planetary science, in that situation, is not about declaring a winner too early. It is about carefully laying out what each version of events would predict, and then going to find the one measurement, the one sample, the one new piece of evidence that only one of the stories can explain. That is the work happening right now, in real laboratories, with real moon rocks, over this exact question. We are in the middle of the investigation, not at the end of it, and that is a thrilling place to be. So let us do what the scientists do. Let us take the two suspects seriously, one at a time, and follow each of them as far as the evidence allows. We will start with the more dramatic of the two, the one that most of the headlines led with, the one that treats the buried mass as the fossil of a catastrophe. We are going to go back 4 billion years to the young moon and watch the day the crater was made. Because if the leading theory is right, then the thing buried under the South Pole Aitken Basin is not really a lunar feature at all. It is the corpse of a visitor, a piece of something that came screaming out of the early solar system and buried itself in the moon so violently that it is still there, all this time later, refusing to sink. And to understand how that could possibly be true, we have to understand what happens when two worlds collide. Part 5. The Suspect from Space. To understand the first suspect, you have to go back to a time on the moon that has no witnesses and no records, roughly 4 billion years ago. The solar system then was a far more dangerous place than the calm, orderly arrangement of planets we live in now. The 8 planets had mostly formed, but the space between them was still littered with leftover debris, the scraps and rubble of planet building, everything from grains of dust to boulders to mountains to bodies hundreds of kilometers across. These were the leftovers, the objects that never got swept up into a planet, and they were still falling. Collisions on a scale we can barely imagine were not rare events. They were the normal condition of the young solar system, part of how it finished settling down. The moon we see, cratered from pole to pole, is a monument to that era. Nearly every crater you can see through a backyard telescope is a scar from something that hit it during those violent early ages. Most of those impacts were small, but every so often something enormous came in, and the object that made the South Pole Aitken Basin was among the largest that ever struck the moon, and left a scar we can still read. We do not know its exact size because the thing itself was destroyed in the impact, but from the size of the crater it left, scientists estimate the impactor was on the order of a few hundred kilometers across, or at the very least many tens of kilometers, a small world in its own right. And crucially, an object that large would not have been a simple, uniform ball of rock. Bodies above a certain size, when they form, tend to separate out inside, the same way the Earth and Moon did. The heaviest material, the iron and nickel and other metals, sinks toward the centre and forms a dense metallic core, while the lighter rock floats above it as a mantle and crust. This process is called differentiation, and it means that a large asteroid is often built like a planet in miniature, a rocky shell wrapped around a core of metal. Remember that metal core. It is the entire point of the first theory. Now let me put you at the scene, because the numbers alone cannot carry what this was. Imagine you are floating in space above the far side of a young moon, 4 billion years ago. The surface below you is darker than the moon we know, its crust freshly hardened over an interior that has barely finished cooling, still warm to its bones. There is no life anywhere in the solar system yet, or if there is, it is nothing more than the faintest chemistry stirring in Earth's new oceans. Everything is young. And then, out of the black it comes, the impactor, an object tens of kilometers across at least, a rogue mountain, a small planet gone astray, moving at a speed that would cross the distance from the Earth to the moon in a matter of hours. It does not slow down. There is no air to slow it. It simply arrives. The moment it touches the surface, the physics stops resembling anything in ordinary life. At those speeds, solid rock does not behave like something hard. It behaves almost like a liquid, because the energy of the impact is so overwhelming that the strength of stone means nothing. There is a flash of light brighter than the sun, as an unimaginable amount of motion turns instantly into heat. A shock wave races outward through the body of the moon, moving through solid rock the way a ripple moves across a pond, and where it passes the ground heaves and flows. A hole opens in the moon that is deeper than any mountain on Earth is tall and wider than an ocean, and out of it, in every direction, molten rock is flung thousands of kilometers, some of it hurled clear off the moon entirely into space. The entire moon rings from the blow, vibrating like a struck bell, a vibration that would take hours to fade. And in the middle of all that violence, the impactor itself is annihilated. Its rocky shell is vaporized and melted and scattered. But its metal core, that dense center of iron and nickel, does not simply vanish. It is torn apart, shattered, and driven down into the churning half-molten mantle of the moon. Then, slowly, over hundreds of thousands and then millions of years, everything begins to cool. The glow fades from the wound, the flung rock settles or freezes in flight. The ringing dies away, the enormous bowl of the crater hardens into the shape we can map today. And the metal, the scattered remains of that asteroid's core, is now buried far down inside the moon, held in rock that is stiffening around it, cooling, going still. If the first theory is right, that is the moment the mass anomaly was born. Not manufactured, not placed, not designed. Simply the frozen wreckage of a collision, sealed inside the moon at the instant it happened, and left there while the universe went on without it. On the blue world hanging in the moon sky, the one with the new oceans, nothing yet could crawl or swim or breathe. By the time anything could, by the time there were creatures on Earth with eyes to look up, the buried metal had already been waiting, motionless, for billions of years. And here is a thought worth holding, because it connects that ancient violence to the calm we take for granted. The same era that carved this scar, the same age of collisions and falling mountains, is the age that shaped the moon into the steady companion we depend on. The moon does not just decorate our sky. Its gravity steadies the tilt of the Earth, keeping our seasons regular over long stretches of time instead of letting the planet wobble wildly. It raises the tides that may have helped stir life along in the shallows. The moon that helped make Earth livable was forged and battered in that same violent youth, and the scar we are studying and the stability we enjoy are, in a sense, products of the same rough process. Creation and catastrophe were not opposites back then. They were the same event, seen from different distances. To really grasp what an impact on this scale means, it helps to compare it to the impacts we do have some cultural memory of, because it reveals just how far beyond them this was. The impact most people have heard of is the one that ended the age of the dinosaurs on Earth, roughly 66 million years ago, when an object several kilometers across struck what is now the Gulf of Mexico. That single impact darkened the skies, triggered global fires and tsunamis, and wiped out most of the species alive at the time. It was one of the most consequential events in the history of life on our planet, and the object that caused it was perhaps 10 or 15 kilometers across. Now consider that the object that carved the South Pole Aitken Basin may have been many tens of kilometers across, possibly far more, an impactor not a few times but potentially dozens of times larger in scale, slamming into a body only a quarter the size of Earth. The energy involved is almost impossible to hold in the mind. If the dinosaur killer reshaped the surface of the Earth, the South Pole Aitken impactor reshaped an entire hemisphere of the moon and left a scar that 4 billion years of time has not erased. And here is a detail that makes the ancient violence feel less remote, that ties it directly to the ground you stand on. The reason the moon is covered in craters and the Earth is not that the Earth was spared. The Earth was struck just as often, probably more often, because it is larger and its gravity pulls in more debris. The difference is that the Earth is a living, active planet, with wind and rain and oceans and shifting continents that erase its scars over time, healing the surface again and again across the ages. The moon has none of that. It has no air to carry weather, no water to wear things down, no drifting plates to recycle its crust. So the moon kept every wound it ever received, preserved almost perfectly, a frozen record of a bombardment that battered both worlds. When you look at the cratered face of the moon, you're looking at a history the Earth also lived through, but wiped clean. The moon is the memory the Earth threw away, and the South Pole Aitken Basin is the largest single entry in that memory, the record of a day so violent that, on any living planet, it would have been erased long ago, but on the still and airless moon, it remains, holding whatever it buried exactly where the impact left it. I keep coming back to that word, buried, because it is the pivot of the whole asteroid theory, and it carries a strange emotional weight when you really consider it. If the leading explanation is right, then what is down there is not lunar rock at all. It is the remains of another body entirely, an object that formed somewhere else in the young solar system, lived its own separate existence for however long, and then died in a single instant when it struck the moon. Its outer layers were vaporized and scattered, but its dense inner core, its metal, was driven into the moon and trapped, and it has been entombed there ever since, wearing the moon around it like a tomb it can never leave. There is something almost mournful in that image, if you let yourself feel it. A whole world reduced to a buried stain of metal, held for 4 billion years inside the body of the thing that killed it, unseen, unmarked, unmourned, until a species on a nearby planet built machines sensitive enough to feel the faint pull of its grave. That, if the theory holds, is what we found. Not a lunar feature, a headstone. But the asteroid theory, dramatic and satisfying as it is, has a serious problem to answer. If that buried metal is really the shattered core of an ancient impactor, then it is sitting in the wrong place, and it has been sitting in the wrong place for 4 billion years. Dense metal, far down inside a warm world, is not supposed to just stay put. It is supposed to sink, and the fact that this has not sunk is either the theory's fatal flaw or the most interesting clue in the entire case. Part 6. The thing that should have sunk. Let me explain the problem carefully, because it sits at the centre of why this is a real mystery and not a solved one. Everything in the universe with mass is pulled by gravity, and inside a planet or a moon, that means heavy things sink and light things float, given enough time and enough heat to let the material move. This is not a subtle effect. It is the reason the Earth has an iron core at all. When our planet was young and molten, the heavy metals drained down through the lighter rock and collected at the centre, while the lighter material rose to form the mantle and crust above. The moon did the same thing, on a smaller scale. It has its own small metallic core at its centre, formed the same way, by dense material sinking as far down as it could go. This sorting of a world by density is one of the most reliable things that happens to a large body in space. Heavy goes down, light comes up. That is simply how it works. So now look at the anomaly again with that rule in mind. Here is a concentration of dense metal, by far the heaviest kind of material a young moon would contain, and it is sitting in the mantle hundreds of kilometers above the core where the truly dense material is supposed to end up. And it has been sitting there, apparently for 4 billion years, in a moon that was warm enough in its youth for material to move around. By every ordinary expectation, that metal should have drained downward long ago and merged with the moon's own core, disappearing into the centre and leaving no trace in the mantle for Grail to detect. The fact that it is still up there, still concentrated, still bending the crust, is genuinely strange. It is like dropping a cannonball into a barrel of honey 4 billion years ago and coming back today to find it still floating halfway down, having never reached the bottom. Something is keeping it suspended, and if the asteroid theory is going to survive, it has to explain what. This is exactly the problem the James team took on, and their proposed answer is clever, and it hinges on one word: dispersed. Picture the difference between two ways that asteroid core could have ended up in the mantle. In the first way, it stays whole. The metal core punches into the moon as a single compact lump, a solid ball of iron and nickel, and settles in the mantle as one dense object. If that is what happened, then yes, it should sink, because a large concentrated mass of metal will steadily press down through the surrounding rock and work its way toward the centre over time. A compact core would not survive 4 billion years in the mantle. It would be gone. But there is a second way, and it changes everything. Suppose the impact was so violent that the metal core did not stay whole at all. Suppose it was shattered, torn apart, and sprayed through the mantle as an enormous cloud of separate droplets and fragments, scattered across a huge region of rock rather than gathered into one blob. That distinction matters enormously, because a scattered spray of metal behaves very differently from a solid lump. When the metal is broken into countless small pieces mixed through a large volume of rock, each individual piece is surrounded by rock and has to fight its way down through it more or less on its own, and small pieces sink far more slowly than a big concentrated mass does. Spread the same total amount of metal thinly enough through a large enough region, and it can effectively become stuck, suspended in the surrounding rock, unable to gather itself back together and unable to drain downward, before the moon cools and hardens and freezes the whole arrangement in place. The James team ran computer simulations of exactly this kind of giant impact, and they found that under the right conditions the numbers work. A sufficiently dispersed asteroid core could indeed remain suspended in the moon's mantle, held there right up to the present day, rather than sinking to the core. In other words, the very violence that would destroy a compact core is what could save a scattered one. The impact that should have driven the metal down instead blew it apart so thoroughly that it got trapped. If that is what happened, then the picture of the buried mass shifts in a way I find genuinely haunting. It is not a single buried cannonball, a neat metal ball you could point to. It is more like a frozen storm, a 4-billion-year-old spray of alien metal hanging suspended through hundreds of kilometers of lunar rock. Droplets of iron from a destroyed world scattered and locked in place at the instant they stopped moving, like sediment stirred into water that never quite settled to the bottom. The anomaly, on this reading, is not really an object at all. It is a moment, preserved. It is the exact configuration of a catastrophe, flash frozen, the last instant of a dying asteroid held motionless inside the moon for longer than there have been continents on Earth. Let me push a little harder on the honey and cannonball image, because it captures the puzzle so well that it is worth taking seriously rather than as a throwaway line. Imagine an enormous barrel of thick honey, and imagine dropping a heavy iron cannonball into the top of it. What happens? The cannonball sinks, of course, slowly because the honey resists it, but steadily and surely all the way to the bottom. Given enough time, a heavy compact object in a thick fluid always finds the bottom. Now the young moon, in its warm early days, was not liquid like honey, but over very long timescales its interior could slowly deform and flow, enough that heavy things could work their way downward over millions of years. So a compact lump of asteroid metal in that mantle should, like the cannonball, have found its way down to the moon's own core long ago and vanished from the mantle entirely. The fact that a huge concentration of dense mass is still sitting up in the mantle, 4 billion years later, is the equivalent of coming back to that barrel of honey after an age and finding the cannonball still hanging suspended halfway down, having refused to sink. Something has to explain that refusal, or the whole asteroid story falls apart. And the explanation, dispersal, is genuinely subtle. So let me make sure it lands, because it is the hinge the entire theory swings on. Take that same cannonball and instead of dropping it in whole, shatter it first into a fine spray, thousands upon thousands of tiny metal droplets, and stir them evenly through the entire barrel of honey. Now what happens? Each individual droplet is so small that the honey around it holds it almost in place, and it sinks incredibly slowly, far too slowly to reach the bottom before, in the moon's case, the whole interior cools and stiffens and freezes the droplets where they are. The total amount of metal is exactly the same, but scattered thin, it behaves completely differently from a single lump. It can get stuck. It can hang suspended. And so the very violence of the impact, the thing you would expect to drive the metal down hardest, is precisely what could have saved it from sinking by blowing it apart so thoroughly that it never got the chance. The simulations the James team ran were essentially testing whether the numbers of a real giant impact could produce that fine, suspended spray rather than a compact sinking lump, and they found that under the right conditions they could. But I promised you honesty, and honesty means holding this idea to the same standard we would hold any other, even when it is elegant, even when we like it. The dispersal explanation is possible. The simulations support that it could happen. What they cannot do is prove that it did happen, because they depend on assumptions we cannot fully pin down 4 billion years after the fact. The exact speed of the impactor, the exact angle it struck at, its exact size and makeup, and the exact state of the moon's interior at that moment. Nudge those assumptions, and the outcome can shift. This is the honest limit of the leading theory, and it is not a small one. It means that even the favoured explanation for the buried mass rests on a clever escape hatch that has been shown to be plausible but not confirmed. That is not a reason to dismiss it. The asteroid theory remains the front runner for good reasons. The density that fits metal, the certainty that a giant impact really happened right there. But it is a reason to keep the other suspect firmly in the room, because that suspect does not need any escape hatch at all. It does not need to explain why the metal failed to sink, because in that version, the dense material was never a compact lump that had to be rescued from sinking in the first place. Now, I want to be honest with you, because this channel does not sell you certainty it does not have. The dispersed core idea is elegant, and the simulations support that it is possible, but possible is not the same as proven. The models rely on assumptions about the impact speed, the impact angle, the size and composition of the impactor, and the state of the moon at the time, and change those assumptions and the outcome can change too. Showing that something could have happened is a real and valuable achievement, but it is not the same as showing that it did. The asteroid theory remains the leading explanation, the one the researchers themselves favour, in part because the density of the anomaly fits metal so well, and because we know for certain that a gigantic impact happened right there. But it leans on that one clever escape from the sinking problem, and that escape has not been confirmed, which is exactly why the second suspect is still very much in the running. Because there is another way to put dense material into the moon's mantle that does not require any asteroid to survive at all, and it comes from a time when the entire moon was not solid rock, but a churning ocean of fire. Part 7. The Suspect from Within. To meet the second suspect, we have to go back even further, past the age of the great impacts, all the way to the birth of the moon itself. When the moon first formed, it was not the cold, still, grey world we know. It was almost unimaginably hot. The leading idea for how the moon came to be is that a Mars-sized body struck the young Earth in a colossal collision, and the debris blasted off into orbit gradually gathered together and coalesced into the moon. A body assembled that way, out of the heat of a planetary collision, is born molten, and so the newborn moon is thought to have been covered, from pole to pole, by an ocean of liquid rock, a globe of glowing magma perhaps hundreds of kilometres thick. Not a sea of water, a sea of melted stone, red and orange and churning, wrapping the entire moon in fire. Scientists call it the lunar magma ocean, and understanding what happened as it cooled is the key to the second theory. Let me put you above it, because it is one of the most extraordinary scenes in the history of our neighbourhood, and almost no one ever pictures it. Imagine floating high over the newborn moon, before there were any craters, before there was any solid surface at all. Below you the entire world glows. There is no grey, no white, no familiar face. There is only a churning ocean of molten rock stretching over the whole sphere, its surface roiling and shifting, glowing sullen red where it is cooler and brilliant orange and yellow where it is hottest, the whole thing radiating heat into space so fiercely that the young moon shines with its own light. Slow waves move across it. Currents of liquid stone rise and fall. There is no sound because there is no air, only this silent glowing sea of fire turning slowly beneath the black sky, with the young Earth, itself half molten, hanging enormous and close above it. This is the moon in its infancy, and over tens of millions of years this ocean of fire begins very slowly to cool. As it cools, it does something crucial, something that could explain everything. A cooling ocean of molten rock does not freeze all at once, and it does not freeze uniformly. Different minerals crystallize out of the melt at different temperatures, and they have different densities, so they go to different places. The lightest minerals, as they formed, floated upward to the top of the ocean, and over time they accumulated into a pale, buoyant crust, the light-coloured highlands that still cover much of the moon today. The denser minerals sank, and here is the part that matters for our mystery. Near the very end of the process, when most of the ocean had already crystallized and only the last dregs remained liquid, the leftover melt became especially concentrated in certain heavy elements, particularly iron and titanium. From that final, dense, iron and titanium-heavy liquid, minerals crystallized that were heavier than almost anything beneath them, including a dense mineral called ilmenite. And that created a problem, a beautiful, physics-driven problem that may be the origin of the buried mass. The problem is that this dense, late-forming layer ended up sitting on top of lighter material below it, and that is an unstable arrangement. Heavy material resting on light material wants to sink, the same way a drop of dense syrup will sink through water if you let it. And so, according to this theory, that dense oxide-laden layer became gravitationally unstable and began to founder, to peel away and sink downward into the mantle in great, slow, cold blobs, sinking through the lighter rock beneath in a process planetary scientists call mantle overturn. Picture it like a lava lamp running in reverse and in extreme slow motion, over millions of years, with the heavy material breaking loose from near the surface and descending in enormous drips into the interior. The moon, in other words, may have sorted itself out from the inside, with dense material peeling off and sinking long after the surface had hardened. If that is what happened, then the buried mass under the South Pole Aitken Basin is not a piece of any asteroid at all. It is a piece of the Moon's own body, a concentration of those dense late-stage oxides gathered and sunk beneath the basin, perhaps stirred together or concentrated by the great impact that came later and carved the crater above it. On this reading, the mass is not a visitor. It is the Moon's own frozen past, the settled dregs of the ocean of fire it was born in, hidden now beneath the deepest scar on its surface. And this idea is far from a fringe possibility. It has been gaining ground. In the years since the anomaly was announced, researchers have published a series of studies exploring exactly this kind of process. Work published in 2022 examined how the South Pole Aitken impact itself could have triggered and organised a moon-wide overturn of that dense material. A study in 2025 reported chemical fingerprints, vestiges of exactly the kind of ilmenite-laden layer the theory predicts buried in the Moon. Piece by piece, the case that the Moon's own internal chemistry could produce dense buried masses has been getting stronger. I want to linger on that ocean of fire a little longer, because it is one of the most underappreciated chapters in the whole story of the Moon, and it reframes what the Moon even is. We tend to think of the Moon as the very definition of a dead, cold, unchanging place, and today it largely is. But that grey stillness is the end state of a body that began in almost inconceivable heat and violence. For a stretch of time near its birth, the entire surface of the Moon was molten, glowing, churning, a world-spanning sea of liquid rock with no solid ground anywhere on it. Everything you can point to on the Moon today, every highland, every crust, grew out of that cooling ocean, crystallized from it like frost forming on a window, only in reverse, from the top down and the bottom up at once. The pale highlands that make up so much of the Moon's surface are, quite literally, the froth of that ocean, the lightest minerals that floated to the top and were left behind as a crust when everything hardened. When you look at the bright parts of the Moon, you are looking at the scum of a frozen sea of fire. And if the second theory is right, the buried mass is the opposite, the heaviest dregs of that same sea, the material that sank instead of floating, hidden now far below. The specific mineral at the centre of this theory has a name, ilmenite, and it is worth knowing a little about it, because it is the quiet protagonist of the second suspect. Ilmenite is an oxide of iron and titanium, a genuinely dense mineral, and it is thought to have crystallized late in the cooling of the magma ocean, near the very end when the last of the melt had become concentrated in exactly those heavy elements. The trouble ilmenite causes is a matter of simple physics. When it formed near the top of the still cooling Moon, and it was denser than the material beneath it. Dense material sitting on top of lighter material is unstable, the way a layer of oil sitting beneath a layer of water is unstable, wanting to swap places. And so, according to the theory, this dense ilmenite-bearing layer began to sink, to peel away in great cold slabs and blobs and founder down into the mantle, driving a slow, world-scale churning that planetary scientists call overturn. The buried mass, in this reading, is where a great deal of that sunken dense material ended up gathering, concentrated beneath the enormous basin, a pooled remnant of the Moon's own frozen ocean. What makes this idea so hard to dismiss is that it has kept gaining evidence rather than losing it. When the anomaly was first announced, the sunken oxide explanation was mentioned almost as a secondary possibility, a runner-up to the dramatic asteroid story. But in the years since, a series of studies has strengthened it. Research published in 2022 explored how the South Pole Aitken impact itself could have triggered and organised exactly this kind of moon-wide overturn, tying the crater and the sinking dense material together into one connected event. And a study in 2025 reported finding actual chemical fingerprints, physical vestiges of just the kind of ilmenite-bearing layer the theory predicts buried in the Moon. Each of these results is a brick in a slowly rising wall, and the wall is on the side of the argument that says the Moon may have made this mass itself. None of it is conclusive yet, but it means the second suspect is not fading. If anything, it has been getting stronger while we watched, which is a large part of why nobody can close the case. So now you can see the shape of the real mystery and why it refuses to resolve. Two completely different stories, each grounded in solid physics, each supported by real evidence and each explaining the same enormous buried mass. One says a killer fell from the sky, was torn apart, and left its scattered metal core trapped in the moon forever. The other says the moon made the mass itself, out of its own molten beginnings, and simply buried it under its greatest wound. Both fit the weight, both fit the depth, both fit the density, and no measurement we currently have can cleanly tell them apart. The gravity map that found the mass cannot see what the mass is made of. It can only feel how heavy it is and how far down it goes, and on those numbers, both suspects have an alibi that holds. Which brings us to a further layer of the puzzle, because to really understand this buried mass, you cannot look at it in isolation. You have to zoom out and look at the whole moon and confront the fact that the two sides of it do not match, and that mismatch, that ancient lopsidedness, may be the biggest clue of all. Part 8. The scar that made the moon lopsided. We touched on this earlier, but now it is time to look straight at it, because it is one of the great unsolved puzzles of lunar science, and it wraps around our buried mass like a hand around a stone. The two sides of the moon do not match, and they do not match in almost every way you can measure. The near side, the face we see, is lower, flatter, and covered in those enormous dark plains of frozen lava, the Maria, which make up a substantial fraction of that hemisphere. The far side has almost none of them. Where the near side is smooth and dark, the far side is rugged and pale and cratered, and its crust is significantly thicker, in places by tens of kilometers. It is as if the moon were assembled from two different worlds, a smooth one and a rough one, welded together along a seam we cannot see. Scientists call this the lunar dichotomy, and they have been trying to explain it for more than half a century without full agreement. Why should the two sides be so different? The moon formed as a single body, so you would naively expect it to be more or less the same all the way around, the way most large round objects in space are broadly similar from one side to the other, but the moon is not. Something happened early in its history that broke the symmetry, that made one hemisphere fundamentally different from the other, and there are several ideas about what that something was. One idea points to the way the moon cooled while it was tidally locking onto the Earth, with one side always facing our warm young planet and the other facing cold space, which could have made the two sides crystallize differently. Another idea, a fascinating one, suggests that the moon may once have had a smaller companion moon of its own, and that this second small moon eventually drifted into the far side and merged with it in a slow collision, splattering extra crust onto that hemisphere and making it thicker. But there is a third possibility, and it brings us right back to the crater we have been standing in this whole time. The South Pole Aitken impact was so colossal that it could not have been a merely local event. An object large enough to gouge a basin 2,500 kilometers wide and 13 kilometers from rim to floor would have delivered an amount of energy into one hemisphere of the moon that is difficult to overstate. It would have heated an enormous volume of the interior, thrown material across enormous distances, and profoundly disturbed the arrangement of the moon's insides on that side. And a growing body of research argues that this single impact may be a major part of why the two faces of the moon diverged. The energy of the strike could have redistributed heat-generating elements, concentrated certain materials in one hemisphere, and helped drive the kind of internal overturn we talked about, tilting the whole subsequent history of the moon toward the lopsided body we see. Recent work has gone even further, using the exact shape of the basin and the chemistry of the materials splashed out around it to argue that the impactor came in at a particular angle, digging up and spreading out ancient late-stage magma ocean material across the surface. Do you see how the threads pull together here? If that line of research is right, then the buried mass and the two-faced moon are not two separate mysteries at all. They are two symptoms of the same ancient catastrophe. The impact that carved the South Pole Aitken Basin may have, in a single stroke, buried the mass we are hunting and helped make the entire far side of the moon different from the near side. The thing at the bottom of the crater might be a piece of the very event that gave the moon the split identity we still cannot fully explain. Which means that when you ask the simple question, what is buried under the moon, the answer keeps refusing to stay simple. It keeps opening outward into the question of how the crater formed, and then into the question of why the moon has two different faces, and then into the question of how the moon was made in the first place. The buried mass is not an isolated oddity. It is a thread, and when you pull it, you find it is stitched into the deepest questions we have about our neighbour's whole life story. The lunar dichotomy deserves a little more attention, because once you understand how strange it is, the buried mass stops looking like an isolated oddity and starts looking like one piece of a much larger unsolved picture. Consider just how thoroughly the two hemispheres disagree. The crust on the far side is thicker than on the near side, in places dramatically so. The near side is draped in enormous sheets of dark volcanic rock, while the far side has almost none. The distribution of certain elements, the ones that produce heat as they decay, is skewed heavily toward the near side. Even the overall shape is off, with the Moon's centre of mass not sitting exactly at its geometric centre, but shifted toward the Earth. Almost every way you can measure the Moon, the two sides come out different, and they come out different in ways that seem to be connected to one another, as if a single underlying cause tilted the whole body in one direction early on. Explaining that one underlying cause is one of the enduring goals of lunar science, and it has resisted a clean answer for over 50 years. That is why linking the buried mass to the dichotomy is such an appealing move, and why researchers keep pursuing it. If you could show that the South Pole Aitken impact was powerful enough to have set the whole lopsidedness in motion, then you would kill two mysteries with one stone. The energy of that impact would have been enough to melt and stir an enormous volume of the Moon's interior, to redistribute the heat-generating elements, and to push around exactly the kind of dense material the overturn theory depends on. In that picture, the impact did not just leave a crater and bury a mass. It nudged the entire subsequent history of the Moon onto a different track, making one hemisphere fundamentally unlike the other, and the buried mass is simply the most concentrated surviving piece of that reorganization. It is an elegant idea, still being tested and argued over, but the appeal of it is obvious. It takes two things that look like separate puzzles, the weird weight and the two-faced Moon, and suggests they might be the same story told at different scales. And this is the deeper lesson I keep taking from the whole affair, the thing that makes it more than a single curious fact. In science, and maybe in life, the biggest questions are rarely isolated. Pull on one loose thread and you often find it is tied to another, and another, until you realize you're not tugging at a single anomaly, but at the edge of an entire tapestry. The buried mass under the Moon looked, at first, like a self-contained puzzle, a strange heavy thing in one spot. But follow it honestly and it leads you into the question of how the crater formed, and that leads into the question of why the Moon has two different faces, and that leads into the question of how the Moon was born and how it cooled and how it sorted itself out over billions of years. The mass is a doorway, and behind the doorway is not a small room but the whole life story of our nearest neighbour, most of which we are still, remarkably, in the process of learning. For a body we have stared at every single night of our existence, the Moon has an astonishing amount left to tell us. And this is where I think the honest wonder of the thing lives, more than in any single answer. We're used to thinking of the Moon as finished, as static, as a done thing, a plain grey ball that has been hanging up there unchanged forever. But the Moon we see is the survivor of a wildly dramatic history, a body that was born in fire wrapped in an ocean of molten rock, sorted from the inside out as it cooled, battered by falling worlds, and split into two mismatched faces by forces we are still arguing about. The buried mass is a piece of physical evidence from that history, a clue left at the scene, still sitting where it came to rest. Reading it is like finding a single strange bone from an animal no one has ever seen, and trying to reconstruct the whole creature from the shape of that one bone. We're not there yet, but every year the picture sharpens, because for the first time in history, we're no longer limited to studying the far side from orbit. We have started to go there, we have started to land on it, and to bring pieces of it home, and that changes what is possible. Part 9. A world full of hidden weights. Before we go to the far side ourselves, I want to widen the lens for a moment, because there is something you should know that makes the buried mass feel less like a freak accident and more like the largest example of a pattern. The South Pole Aitken anomaly is not the only hidden weight inside the Moon. It is the biggest and the strangest, but it belongs to a family, and that family has been puzzling scientists since the earliest days of the space age. To meet the rest of the family, we have to go back to 1968, a year before the first humans walked on the Moon, when NASA was flying robotic spacecraft in lunar orbit to scout landing sites for the coming Apollo missions. Those early orbiters kept doing something odd. As they flew over certain regions of the Moon, particularly over the large round dark maria on the near side, they would get subtly pulled off course. Their orbits would dip and shift in ways that the known shape and mass of the moon could not account for. Something beneath those great circular planes was pulling harder than the surrounding terrain, tugging the spacecraft down as they passed over. Scientists studying the tracking data realized they were seeing concentrations of extra mass hidden beneath the surface, and they gave them a name that has stuck ever since. Mascons, short for mass concentrations. The moon, it turned out, was not a uniform ball of rock with its weight spread evenly around. It had lumps. It had regions where extra mass was piled up below the surface, pulling harder on anything that flew overhead, and those lumps were significant enough that they genuinely mattered. They mattered, in fact, for the most human reason imaginable. When you're trying to land people on the moon, you need to predict the path of your spacecraft with great precision, and mascons made that prediction harder. Their invisible tugs could nudge an orbiting craft off its expected track, and the Apollo mission planners had to account for them to navigate safely and set their landers down where they intended. Think about that. Concentrations of mass buried inside the moon, left over from events billions of years ago, reached up and touched the paths of the spacecraft carrying the first people ever to visit another world. The hidden interior of the moon was not some abstract academic curiosity. It was a practical hazard that engineers had to respect to keep astronauts safe. The buried weight of the moon has always reached up and shaped what happens above it. For decades, though, our picture of the mascons was crude. We knew they were there and roughly where they were, but we could not map them in fine detail. That is exactly what Grail, our two little formation-flying probes, finally changed. With its extraordinarily precise gravity map, Grail revealed the mascons in full, sharp detail for the first time and helped explain what most of them are. The classic near-side mascons, the ones beneath the Great Circular Maria, turned out to have a relatively tidy explanation. They are associated with dense material that welled up from the mantle beneath large impact basins, combined with the heavy iron-laden lava that later flooded in and filled those basins. Big impact. Dense mantle material rises to fill the gap, lava pools on top, and you get a concentration of mass. It is not simple, exactly, but it makes sense, and it fits what we see on the surface, because those basins are filled with visible dark lava. But the South Pole Aitken anomaly does not fit that tidy story, and that is precisely why it stands apart from its relatives. It is far larger than the classic mascons. It reaches far deeper, hundreds of kilometers down into the mantle, rather than sitting relatively near the surface. And critically, it is not simply explained by a pool of visible lava filling a basin, the way the near-side mascons are. The South Pole Aitken Basin is not flooded with the kind of dark mare lava that fills the near-side basins. Its buried mass is something else, something deeper and stranger, whose origin the researchers themselves flagged as an open question rather than a solved one. So the anomaly is at once a member of a known family and the black sheep of it, the one relative whose story does not match everyone else's. It is a mascon, yes, but a mascon on a scale and at a depth that breaks the usual explanation. It is worth appreciating just how surprising the very existence of mascons was when scientists first ran into them, because it overturned a comfortable assumption. Before the space age, the reasonable expectation was that the moon would be more or less uniform inside, its mass spread evenly, its gravity smooth and predictable from place to place. A dead ball of rock, after all, ought to be a simple thing, so when the early orbiters kept getting tugged off their expected paths as they crossed certain regions, it was genuinely puzzling. The moon's gravity was not smooth, it was bumpy, it had concentrations, hot spots of extra pull, buried under specific places, and that meant the inside of the moon was not uniform at all but organised, structured, marked by its history in ways that reached up and grabbed at passing spacecraft. The discovery of mascons was one of the first hints that the moon was a far more complicated and interesting body than the simple grey disk it appeared to be, and every mission since has only deepened that impression. And the mascons tell a story about the moon's violent past that connects directly to our buried mass, because most of them are, in one way or another, the fingerprints of impacts. The great circular basins that host the classic near-side mascons were themselves carved by enormous ancient collisions, and the buried weights beneath them are tied to how the moon responded to being hit, with dense material rising from below to fill the wounds and heavy lava later flooding in on top. So when you map the mascons, you're in a real sense mapping the record of the moon's bombardment, the set of places where it was struck hard enough to leave a lasting mark not just on its surface but in the arrangement of its interior. The South Pole Aitken anomaly is the extreme end of that record, the mark left by the single most violent impact the Moon ever clearly survived, and it is fitting that it should be the largest and strangest buried weight of them all. It is the deepest signature of the roughest day in the Moon's long history. There is a humbling thought in all of this, and it is one I find myself returning to whenever I think about how little we truly know the objects we take for granted. The Moon is, by an enormous margin, the most studied, most observed, most familiar body in the entire sky, apart from the Earth itself. We have watched it for all of human history. We have sent dozens of missions to it. We have walked on it. We have brought its rocks home, and still, its interior is lumpy with buried masses whose full stories we do not know, hiding concentrations of material whose origins we are still debating, keeping secrets in the one place we cannot easily look, its inside. If the Moon, our closest and best-known neighbour, can still surprise us this thoroughly, can still hide something 5 times the size of Hawaii, and leave us arguing about what it is, then it is worth staying humble about how much remains unknown everywhere else, on every other world, in every dark corner of a solar system we have barely begun to explore. Familiarity is not the same as understanding. We know the Moon's face. We're only just beginning to know its depths. I find this reframing genuinely changes how I look at the Moon, and maybe it will for you too. We tend to imagine the Moon as the simplest kind of object, a plain dead rock, uniform and inert, the least mysterious thing in the sky precisely because it is so familiar and so close. But that picture is wrong. The Moon is a body with hidden weights sewn into it, a dozen buried concentrations of mass scattered through its interior, each one a frozen record of some event in its violent past, each one reaching up invisibly to tug at whatever passes overhead. The reason you cannot simply fire a spacecraft at the Moon and forget about it, the reason navigators have to keep the mascons in mind to this day, is that the inside of that world is lumpy with buried history, and the largest, deepest, most puzzling of all those buried lumps is the one we came here to find, sitting under the greatest scar, on the side we never see. Which is exactly why, in the last few years, we have finally started going there in person to have a proper look. Part 10. Reaching the Hidden Side. For almost all of the time humans have studied the Moon, the far side was a place we could only look at, never touch. We could photograph it from orbit, map its shape with lasers, and feel its buried weight with gravity, but no machine had ever actually landed there and stood on that hidden ground. That barrier fell in January of 2019, the same year the mass anomaly was announced, when China's Chang'e 4 spacecraft did something no mission had ever done before. It touched down on the far side of the Moon, and not just anywhere on the far side. It landed inside a crater called von Karman, which sits on the floor of the South Pole Aitken Basin, the very basin under which our mystery is buried. For the first time in history, a working machine was sitting on the surface directly above the hidden mass, in the exact region the gravity map had flagged. Landing on the far side is much harder than landing on the near side, and the difficulty comes from that same fact we keep returning to. The far side never faces Earth, which means a spacecraft sitting on it cannot talk to us directly. Its radio signals cannot reach across the body of the Moon. To solve this, the mission had to first place a separate relay satellite out beyond the Moon, positioned so that it could see both the far side and the Earth at once, and bounce signals between them. Only then could a lander on the far side send its data home. That extra step, that need for a relay just to say hello, is a small reminder of how genuinely cut off the far side is, how it sits in a kind of permanent communication shadow, and yet we reached it. We put a lander and a small rover onto the floor of the largest crater in the solar system and started studying the ground up close. Then, in June of 2024, we went a step further, and this is the part that gives me chills every time I think about it. China's Chang'e 6 mission landed in the same basin, on the far side, and did something no one had ever done in the entire history of our species. It reached down, gathered up material from the surface, and carried it back to Earth. Nearly 2 kilograms of it. For the first time ever, we held in our hands pieces of the far side of the Moon, rock and dust from the one large surface in our sky that no human had ever seen until a single lifetime ago, scooped from the floor of the deepest scar in the solar system, sealed in a container, and flown across 250,000 miles of space to a laboratory on Earth. I want you to slow down with me here and feel the weight of that, because it is easy to let it become just another line in a list of missions, and it is so much more than that. For the entire span of human existence, the far side of the moon was the great untouchable place. Every civilization that ever rose and fell, every telescope ever built, every myth ever told about the moon, all of it happened without a single soul ever seeing the other side, let alone touching it. It was, in the most literal sense, beyond reach, hidden not by distance alone, but by the fixed geometry of the moon's own turning. And then, within one human lifetime, machines built by people not only saw it and mapped it, but landed on it and closed a scoop around a piece of it and brought it home. Somewhere on Earth right now, under laboratory lights, there is rock that spent 4 billion years on the side of the moon we were never meant to see, being studied grain by grain, being read like the pages of a book we did not know existed. The hidden half of our oldest companion is no longer entirely hidden, and the answer to what lies buried beneath it may already be sitting in a sealed drawer somewhere, waiting for someone to finish reading it. Because here is why those returned rocks matter so much for our specific mystery. Beyond the sheer wonder of having them, gravity can tell you that a mass is there. It can tell you how heavy it is and how far down it sits. But gravity cannot tell you what the mass is made of. Only actual material can begin to do that. And the South Pole Aitken impact was so violent and dug so far down that it should have thrown up material from far inside the moon, from depths that, anywhere else on the surface, would be sealed away forever beneath kilometers of crust. The floor of that basin is a kind of window into the moon's interior, a place where interior material was blasted up to where we can reach it. So samples from that basin are not just moon rocks. They are in a sense samples of the moon's insides, and scientists can hunt through them for chemical fingerprints. Does the chemistry carry the signature of iron and nickel from a shattered asteroid core? Or does it carry the mark of titanium-laden oxides from a frozen ocean of magma? The buried mass itself, 300 kilometers down, we will almost certainly never touch. No drill will ever reach it. But the chemistry of the region it hides beneath is now, for the first time, physically here, on Earth, in human hands. I want to dwell on what it actually took to reach that ground, because the difficulty of it deepens the achievement. Landing anywhere on the moon is hard enough, but the far side adds a problem that sounds almost like a riddle. How do you send commands to and receive data from a machine sitting on a surface that can never see the Earth? The moon's own body blocks every direct signal. The answer was to launch, ahead of the lander, a dedicated relay satellite and park it in a special spot in space beyond the moon, a place where it could keep both the far side surface and the Earth in view at the same time, and act as a messenger between them. Every instruction to the far side lander, every picture and measurement it sent back had to hop through that relay. Think about the layers of planning that requires, the need to build and launch an entire second spacecraft just to have a conversation with the first. It is the kind of obstacle that only exists because of the strange geometry we have been circling this whole time. The permanent turning away of the far side, and overcoming it was a real feat of patience and engineering. And then to go beyond landing to actually collect material and bring it back crosses into something that still feels almost mythic when you say it plainly. A robotic arm, on the far side of the moon, on the floor of the largest crater in the solar system, reached down, gathered up rock and dust, sealed it away, lifted off from a surface no vehicle had ever launched from before, and flew it home across the gulf between the moon and the Earth. Nearly 2 kilograms of the far side delivered into human hands. When those samples arrived, scientists were holding, for the very first time, physical pieces of the hemisphere that had been hidden from every human who ever lived until a single lifetime ago. It is worth letting the sheer improbability of that sink in, because it is the kind of thing that would have seemed like pure fantasy to almost everyone who has ever gazed up at the moon and wondered what was on the other side. We did not just wonder. We went, and we reached down, and we brought a piece of the answer back. Those returned rocks are being studied right now, and this is the part that turns the whole mystery from a closed historical puzzle into a live and unfolding one. Scientists can measure the exact chemistry of far-side material for the first time, hunting for the fingerprints that might finally distinguish the two suspects, the iron and nickel signature of a shattered asteroid or the titanium-heavy oxide signature of a frozen magma ocean. The buried mass itself is far too far down to sample directly, and it always will be. But the great impact that carved the basin flung up material from far inside the moon and scattered it across the floor, so the surface of that basin is, in a real sense, a window onto the interior, and the rocks from it are clues from a depth we could never otherwise reach. The answer to the 4-billion-year-old question of what is buried under the moon may not come from feeling its gravity from orbit. It may come, quietly, from a grain of rock in a laboratory drawer, read carefully by someone patient enough to hear what it is saying. We are right now in the years when that reading is happening. That is the difference between the mystery of a decade ago and the mystery today. 10 years ago, this was a strange signal in a gravity map, an anomaly we could only weigh from orbit and wonder about. Now it is an open investigation with physical evidence being actively examined, with landers on the ground and samples in the lab, and new studies published almost every year. We have not solved it, but we have moved it from something we could only ponder to something we can genuinely work on. And that is an enormous step. Which leaves us with one last honest question to face, before we stand over the buried mass one final time and try to make sense of what it all means. If we have the samples and the gravity maps and the simulations and the landers, then why still can nobody say for certain what the thing is? Why is the truest answer, even now, that we do not know? Part 11. Why nobody can explain it. The honest reason nobody can explain it yet is not a lack of effort, and it is certainly not a secret being kept. It is that the mystery is genuinely hard, in the specific way that the hardest questions about the past are hard. We are trying to reconstruct a single event, or set of events, that happened 4 billion years ago, that left its main evidence buried 300 kilometers underground where we cannot reach it, and that could plausibly have been produced by two entirely different processes that both leave similar traces. The gravity tells us the mass is there and roughly how it is shaped, but two different origins can produce a similar mass. The returned samples give us chemistry from the basin floor, but interpreting that chemistry, deciding whether a given signature points to an asteroid or to the moon's own magma ocean, is subtle, contested work, and different teams read the same data differently. This is a puzzle where almost every piece of evidence is compatible with more than one answer. That is what makes it so stubborn. And I want to be clear about what that uncertainty is and is not, because this is exactly the kind of story that gets twisted. When you see a headline that says scientists have found a mysterious mass on the moon that they cannot explain, there is a strong pull to hear something sinister in it, to imagine that the not knowing means there is something being hidden, or something unnatural, or something that ought to frighten us. So let me dissolve that as plainly as I can. The uncertainty here is not a cover story. It is the visible, published, ongoing process of science working exactly as it is supposed to. The team that found the anomaly wrote up two competing natural explanations in their original paper and stated openly that they could not choose between them. In the years since, other researchers have proposed still more variations, argued with each other in peer-reviewed journals, and sent spacecraft to bring back samples specifically to test the ideas. The raw gravity and topography data are freely available for anyone in the world to check the math themselves. Nobody can explain it does not mean somebody knows and will not tell you. It means the honest, healthy state of a hard problem that several teams are actively racing to solve in full public view. The same goes for the wilder claims, the ones that inevitably attach themselves to a story like this, that the buried mass is some kind of artificial structure, a hidden spacecraft, a base built on the side of the moon conveniently turned away from Earth. I understand the appeal, and I always want to take the underlying sense of wonder seriously, but the actual evidence points firmly away from anything artificial, and it does so for concrete reasons. The gravity data do not describe a compact, contained, structured object. They describe a diffuse concentration of mass spread through hundreds of kilometers of mantle, which is exactly what you would expect from either a shattered, dispersed impactor core or a sunken layer of dense oxides, and nothing like the sharp, localized signal a solid manufactured object would produce. Its density is consistent with ordinary iron-laden rock and metal, not with anything exotic, and its location on the far side is not sinister concealment. The far side faces away from us for one simple, boring, beautiful reason. The moon is tidally locked to the Earth, turning once on its axis in exactly the time it takes to circle us. So the same face is always toward us, and the same face is always away. Anything on that far hemisphere is hidden from us purely by that geometry, not by any design. The mass is almost certainly a natural relic of the early solar system, and that it is natural does not make it small or dull. It makes it a genuine 4-billion-year-old fossil of planetary violence or planetary birth, which is a far better and stranger story than any buried machine could ever be. So let me take you back down one last time, to stand over the thing itself, now that you know what we know and what we do not. Imagine you are back on the floor of the South Pole Aitken Basin, on the far side with no earth in the sky, and the stars hard and unblinking above you, and grey rock to every horizon. You're standing on the deepest scar in the solar system, and everything looks utterly still and ordinary, just another patch of ancient lunar ground. But now you know what is beneath your boots. Straight down, through the crust, through hundreds of kilometres of rock, far below anything you could ever dig to, there is a mass the size of 5 Hawaiian islands, dense and dark and silent, 4 billion years old. It might be the scattered iron core of a destroyed world, frozen mid-fall. It might be the sunken dregs of an ocean of fire the moon was born in. You cannot see it. You will never see it. But it is pulling on you right now, gently, the ground under your feet sagging by more than half a kilometre, toward the weight below, a pull so patient and so old that the crater floor has been bending toward it since before there was anything alive on Earth complicated enough to wonder about it. You're standing on top of something enormous and unexplained, and you can feel its weight in the very ground, and you still cannot say what it is. That is the strangest sensation our nearest neighbour has to offer, and almost no one on Earth even knows it is there to be felt. There is a particular reason the returned samples, as exciting as they are, have not simply ended the debate, and it is worth understanding because it captures why this problem is so genuinely stubborn. The material scooped from the basin floor is surface material, gathered and mixed and reworked over billions of years by the endless rain of smaller impacts that churns the top of the moon. It carries chemical hints about the interior, but it is not a clean, pristine sample lifted straight from 300 kilometres down. Reading the origin of the buried mass from surface rocks is a little like trying to reconstruct the contents of a sealed room by examining the dust that has drifted out under the door over centuries. The dust tells you something. It is real evidence, but it is filtered, mixed, and ambiguous, and reasonable experts can look at the same chemistry and draw different conclusions about what it implies for the mass far below. That is not a failure of the scientists. It is the honest difficulty of inferring something buried past all reach from the traces that happen to survive at the surface. So we are left in a genuinely unusual situation, and I think it is worth naming it clearly rather than papering over it. We have found something enormous. We have measured it carefully. We have 2 good, physically grounded theories for what it is. We have landed on the ground above it and carried pieces of that ground home, and after all of that, the truest thing anyone can say is still, we do not yet know. That can feel unsatisfying if you came looking for a tidy answer, a single revealed truth to walk away with. But I would gently suggest a different way to hold it. The not knowing is not a dead end. It is the exact texture of a discovery still in progress, a mystery caught in the act of being solved, and there are not many of those you get to witness in real time. Most of what we know about the universe arrived long before we were born, already settled. This one is still open, still argued, still being chased with landers and samples and models, right now, in our moment. We're not reading the last page, we're watching the chapter being written, and that, more than any specific answer, is what I would want you to carry away from tonight, especially as you drift towards sleep. The universe is not a finished book with all its secrets already printed. It is still unfolding, still surprising the people who study it most closely, still hiding enormous things in plain sight. The moon has hung in our sky for the entire span of human existence, watched by every person who ever lived, and it has kept this secret the whole time. On the one face it never shows us, waiting for a species clever enough and patient enough to feel the weight of what it was hiding. We have only just become that species. We can feel the weight now. We cannot yet name it. But we are working on it, carefully, honestly, night after night, and the answer is coming. There is no fear in that. Not really, when you look at it straight. There is only the quiet, steady wonder of standing at the edge of something we do not yet understand about the most familiar object in our sky, and knowing that the understanding is on its way. And maybe, standing there, the right response is not fear at all, but a kind of quiet astonishment at where we find ourselves in the history of knowing. We are the first generation of humans who can say the far side of the moon has been touched by human hands. We are the first who can feel this buried weight, the first to argue over what it is, the first to hold pieces of its neighbourhood up to the light. Every generation before us looked at the same moon and saw a finished, familiar, knowable thing. We get to look at it and see a body still full of secrets, with an open question sitting right there in its hidden half, waiting. The not knowing is not a wall. It is an invitation, and we are the ones lucky enough to have arrived just as the door began to open. Part 12. What it means. So let us gather it all together now, at the end, and see what we have really been looking at. Somewhere on the side of the moon that faces permanently away from us, buried more than 300 kilometers below the floor of the largest crater in the solar system, there is a concentration of dense mass so enormous, at least 2.18 quintillion kilograms, that it is bending the crust of an entire world downward and tugging passing spacecraft off their paths. We did not find it by digging or by seeing it. We found it by feeling its weight, by watching two small robots get pulled a fraction faster as they crossed over it, and by carefully subtracting away everything on the surface we could already account for until only the pull of the hidden thing was left. And when we ask what it is, we get two answers, both grounded in real physics, neither one proven. It may be the shattered iron core of an ancient asteroid, blown apart in the impact that carved the crater and scattered so thoroughly through the mantle that it never managed to sink. Or it may be a piece of the moon itself, the dense iron and titanium-heavy dregs of the ocean of molten rock the moon was born in, sunk and gathered beneath its deepest wound. A visitor, or the moon's own frozen past. We cannot yet tell which. Think about what that means for the moon you thought you knew. You have looked at it your whole life. It is the most familiar sight in the night sky, the one thing up there that everyone recognizes, the face that has watched over every human being who ever lived. It steadies the tilt of our planet and keeps our seasons from swinging wildly. It raises the tides. It has lit countless roads home and hung over countless quiet moments. And the entire time, on the side it never shows us, it has been carrying this, something the size of a mountain range, dense and unexplained, sitting in the dark. The face you know is the calm one. The face you know is the front of the postcard, and behind it, the whole time, there was a second world, scarred and lopsided and heavy with buried history, that stayed sealed to us until a single lifetime ago. The moon we have watched every night of our lives turns out to be, in part, a stranger. Not a threat, not a danger, just a stranger, our oldest and closest one, still holding secrets enough to defeat us. I called this a scar at the beginning, the great wound on the far side, and I want to leave you with the way that image changes once you understand what is inside it. A scar is a mark of damage, a record of something that hurt. But a scar is also the only reason the story survives to be read. The South Pole Aitken Basin, that catastrophic ancient wound, is precisely what protected the evidence buried beneath it. Whatever the mass is, it was sealed away 4 billion years ago in a place so far down that nothing could disturb it. No erosion, no weather, no shifting of continents, because the moon has none of those things. The wound became the vault. The disfigurement became the archive. The very violence that scarred the moon is what preserved perfectly the deepest page of its history and handed it forward across 4 billion years to a species that only just learned how to read it. The scar never healed. And because it never healed, it kept the record intact for us to find. That is the thing I keep coming back to, the reason I do not think the honest answer we do not know is frightening at all in the end. We live at the exact moment when this question is open. Not solved, not dark, but open, actively being worked on, with landers on the far side and samples in the lab and the tools that might finally settle it only now coming into our hands. For every human generation before ours, the moon was a finished thing, a plain grey fact hanging in the sky, its secrets either already known or entirely out of reach. We are the ones who get to stand at the edge of a real mystery about our nearest neighbour, feel the weight of something enormous we cannot yet name, and know that the answer is coming, maybe in our lifetimes, maybe from a rock already sitting in a drawer somewhere. The age of discovery is not behind us, tucked away in old books about explorers and sailing ships. It is directly overhead tonight, in the dark half of a moon we thought we already understood. Let me leave you with one last way of seeing it, a way that turns the whole thing gentle. For most of history, people looked at the moon and filled the parts they could not understand with stories, with gods and rabbits and faces, with meaning invented to cover the gaps in knowledge. We do not have to do that anymore, And yet the moon has given us something even better than an invented story. It has given us a real one, an honest mystery, a genuine unsolved question sitting in its hidden half, waiting patiently to be answered by evidence rather than by guesswork. There is a quiet dignity in that. We no longer need to make up what is on the far side of the moon. We can go and find out slowly, carefully, one measurement and one returned rock at a time. And in the meantime, we get to sit with the wonder of it, the knowledge that something enormous and unexplained is really up there, felt but not yet named. I find something deeply restful in that idea, and I hope you do too. We spend so much of our lives feeling that everything worth discovering has already been discovered, that the maps are all filled in, that the age of standing at the edge of the unknown belongs to other people in other centuries. It does not. The edge of the unknown is right there, tonight, 250,000 miles away, on the back of a moon you have seen 10,000 times and never once truly seen all of. The wait is real. The question is real. And the fact that we can feel it at all, that a species on one small world learn to reach out across the dark and sense the pull of something buried inside another, is itself a kind of miracle, quiet and undramatic and easy to miss. We are the ones who get to feel it. We are the ones for whom the moon is not quite finished revealing itself. So the next time you find yourself under a clear sky, look up at that familiar face for a moment, the calm grey one turned toward us, and remember what it is hiding on the other side. Remember that behind that quiet, well-known surface, there is a scarred and unfamiliar hemisphere you will never see from where you stand, and buried within it, sunk deeper than any drill could ever reach, something enormous and dense and old, pulling silently on the rock around it, waiting, as it has waited since before there was anyone here to wonder. We can feel its weight. We just cannot, not yet, say its name. And there is something almost comforting in that, if you let there be, the reminder that even the most familiar thing in your sky is still, at its centre, a question. That the universe has not run out of wonders, and that some of the biggest of them are not out at the far edge of everything, but hidden in plain sight, in the one face we have looked at our whole lives without ever quite seeing the other side. Sleep well. The moon will be there tomorrow night, keeping it secret, and so will we, slowly, patiently, learning how to ask.